Now this is question 8. It's got an asterisk in it on a yellow triangular background. That means it's serious. Now you can do this graphically. I'm not going to do it graphically. I'm going to use a more advanced method and try and get it right operating live here. Let's have a little read together. It says James is researching different bridges on the internet. That's the example of the bridges he's looking at. He finds the following one and one of his websites that he visited. The height above the water of the arch, that's that h there, is given by the formula h equals 2.5 x's, in other words 5x over 2, minus a 20th of an x squared. Very complicated. Where h is the height at a distance x from the bank. Is that alright? So the maximum height is h, and the distance that corresponds to that h is going to be a certain distance x from the bank. Right, here's the question. What width of water is available to a yacht with a mast height of 25 meters? In other words, if I've got 25 meter height, I've got to work out how much leeway I've got to sail under that bridge and not smash my mast as I pass through. Is that alright? Now, if I'm working with a height of 25, I can create a table of values for h from, say, 10 meters up to I don't know, 40 meters, say, going up a few meters at a time, and then calculating the x values appropriately. Well, I'm not going to do that at all. I'm going to solve this quadratic equation. Now look at it carefully. I have got 5x over 2 minus x squared over 20 all comes to 25. Is that alright? So I'm told this equals 25. And if I can work out my x values, it's a quadratic equation, then I'm going to use those rather than draw a graph. Otherwise I'm just left with trial and improvement to work out the value of x that will give me 25 meters. It's really not good at all. So let's just tie this up a little bit. The common denominator will be 20, so it'll be 50x over 20, take away x squared over 20 is 25. Alright, so if I multiply by 20 throughout, I will get this. 50x minus x squared is going to be 20 times 25, 500. Is that alright? Multiplying by 20. So I'll just say what I've done there in a bracket, that's fine. Alright, so that's got rid of the 20 off the bottom. Rearranging this, I'm going to have x squared minus 50x. So take it over and plus it, take it over and minus it, plus 500 equals 0. That's a lovely quadratic formula equation. I can use the formula or I can complete the square. I know this doesn't factorise, I've tried it. Now, I know we're looking at quadratics somewhere way ahead in Unit 3 now, but I'm going to teach you this completing the square right now in order to solve it. Now look, if I break this part open, I go x minus 25 all squared. Now if you were to multiply this out, you'd get x squared minus 25x minus another 25x plus 50 times 50, plus 25 times 25, 625. Essentially I would get x squared minus, that should be equal, shouldn't it? I would get x squared minus 50x plus 625. I don't want 625, I want plus 500. Therefore, if I subtract 125, I've completed that perfect square and made it equivalent to this complete quadratic equation. Now I've just got to solve it. So x minus 25 squared equals 125. Alright, take it over and plus it. Now just get the square root of 125. Now listen, it's quadratic. I can do plus or negative the square root of 125. And then take my minus 25 over and add. So these are my two solutions. It'll be plus or minus root 125 plus 25. Let's just work up here where there's more space. Pick up my calculator. My two solutions are the positive square root of 125 plus 25. Get my answer in a minute. And the negative root of 125 plus my 25. And these are my two answers. So the square root of 125 equals 11.18 plus 25 gives me 36.18 meters away from the bank. Now what about if I've got a negative root? Well, I've got square root of 125 equals still 11.18. Just put a minus in front of it. So it's minus 11.18. Now add on the 25. Comes to 13.82 meters. So the maximum distance I can be away from the bank is going to be 36.18, and the minimum distance, my little x, is going to be 13.82. So therefore I can work happily from 13.82 meters away and up to 36.18. Therefore available width is going to be 36.18 take away 13.82 meters, and that's going to be 36.18 take away 13.82. That gives me 22.36 meters. But look, the mast is, does it say mast here? Yeah, the height of the mast is 25. It doesn't mean that the maximum height of the bridge is 25. So what I've really calculated is this. My 13.82 from the bank is an x value, and my 36.18 is my other x value, because it's a quadratic equation. In other words, I'll be 13.82 from one side and not crash, or 36.18 from the same side and not crash. Is that alright? Therefore my difference between that one and that one is going to be my 22.36 meters. Is that alright? So my height of 25 can sit between there and there. This is the region within which I can actually sail. If I go too far to the left, I'm going to smash it. If I go too far to the right, I'm going to smash it. And these heights is my 25 there and there, and it is not necessarily the height of the bridge. So I've self-corrected in public, and well, you can do that as well. Obviously if you're in an exam and you reconsider, I've reconsidered because it didn't feel right somehow. So really my available width is in fact the maximum distance from one edge, 36.18, minimum distance from the other, from the same edge, 13.82, gives me a width of 22.36 within which I can sail within those two limits there. Alright, so I'm going to stick to that, and that's more in keeping with the 24 that the answer book got using a graph. Well, this is a far more advanced method. Now if you've not completed the square before, this method is called here completing the square. And it is one way of solving a quadratic equation